Hi guys, it is lesson 1-6, classifying polygons tonight, or today, whenever you're doing it this weekend. It starts on page 42 of your textbook. Remember, you do have that online access code now, so if you want to go to that, you can. And the first term we're going to look at is polygon, specifically finding the sides and the vertex. The definition of a polygon is a figure that lies in a plane. And obviously that just means it's two-dimensional. It can be drawn on a piece of paper. And there's a couple of criteria. It must be a closed figure. That means that all the points end up closing up so that there's no gaps. So kind of like fencing in a pen, there's no two pieces that don't come together. Like this would not be a closed figure. So it has to be a closed figure. The vertices are found where the two sides, any two sides come together. The plural of that is vertices, so there's vertexes, but vertices. And when we refer to this as a polygon, you want to list the vertices in order. So you could call it, you could go in any order you wanted, but it could be polygon A, B, C, D, E. It could be polygon D, E, A, B, C, or anything like that. Okay, so take a minute to classify, or to get that definition down. Then we jump into two concepts of classifying polygons as either convex or concave. And kind of the traditional way I've always thought about it is I think about when something caves in, it means the side kind of gets pushed in. So if you could imagine that if these two sides were pushed out, but they're not, they're pushed in, so it's kind of concave in. But here's the formal definition, or one of the way your book talks about it, is with any polygon, if you extend out the sides of the polygon into lines, a figure is considered convex if those sides extended into lines, if those lines never pass into the interior of the shape. So notice as I extend these out, all these little fragments are all staying outside of it. Versus this one that's concave, when I extend out this line segment, notice in this line segment, notice that those line fragments come in to the interior of the shape. That's what makes it concave. So your book shows a couple of examples like these, same concept. So can you please take a minute on your vocab sheet to draw an example of a convex polygon and a concave polygon, and use kind of this drawing notation so that you've got that kind of figured out. Okay, next thing I'd like you to do is to look at these shapes, and on your notes just write A, B, C, and D and quickly classify. Are those convex or concave? And remember, you can pause the video to do that. Okay, the next concept we're going to talk about on the back of your vocab sheet, it goes into the idea of an n-gon. An n-gon is just a polygon with n sides. So remember, a polygon has to be closed, has to have vertices. It can be convex or concave, doesn't matter, but we start to classify those. And I'd like you to take a minute. These are the ones that you need to memorize. So in your notes, a polygon with 3 sides is called a triangle, 4 sides quadrilateral, and so on. We need to memorize and write those down all the way up to 12 sides. And this is found on page 43 of your textbook. So take a minute to fill those out. Anything beyond 12 sides, we just call it an n-gon. So if you have a 17-sided shape, you're going to call it a 17-gon. You're not going to have a specific name for it. Okay? Then we're going to go on to define equilateral and equiangular. In an equilateral polygon, all the sides are congruent. So we're going to make a shape here, and how might we mark that the sides are congruent? We do single dashes here to show that they're all the same length. And equiangular means that your shape has all the same angles. So how might we mark that? To show the angles, we do single arches. And notice I didn't draw this to scale very well, but this shows that all these angles are the same. So take a minute to not only draw the picture, but to put equilateral and equiangular into words, a word definition. And then we're going on to the concept of a regular polygon. A regular polygon has a couple criteria. A polygon's regular, number one, it has to be convex. And it has to be both equilateral and equiangular. So a stop sign is your classic case of a regular polygon. Okay, I can spell. It's an octagon. See if I can draw as well. It's an octagon with all 8 sides congruent and all 8 angles congruent. So it's equilateral, equiangular, and it's convex. So take a minute to look at those and to define that. Okay. So looking at A and B, decide if they are regular, if they're equilateral, equiangular, or regular. So in this case, do you think it's equilateral? Yes, because all the sides are the same length. Is it equiangular? Yes, all the angles are marked. So since it's both and it's convex, that makes it regular. This one over here, is it convex? Yes, it's convex. But notice it's not equilateral. Opposite sides are not congruent, or opposite sides are congruent to each other, but all 4 of them are not congruent to each other. So it's not equiangular or equilateral, but it's also not equiangular. So it's nothing. It's neither regular, equilateral, or equiangular. And the last one I want you to consider is this one. Is it equiangular? Yes. All of the angles marked are 90 degrees. Technically though, if we're marking interior angles, this angle right here is on the interior and those are not. Okay. It is equilateral, but notice it's not convex, so it cannot be regular. Okay. All right, the last thing, or actually, please go now, and I'm going to check this first thing in the morning on Monday, is I'd like you to turn to page 43, and somewhere in your notes, I'd like you to draw guided practice number 1. So page 43, please do guided practice number 1 in your notes. And I'll give you a minute to draw that. And then we're going to finish up with one more word problem. Guys, please, I'm trying to keep the video short, so I'm not having a lot of pause time. So please make sure that you pause the video when I ask you to do something so that you can take a look at it and get done what needs to get done. Okay, let's take a look at this one word problem. It says a table is shaped like a regular hexagon. So in the word problem, since it tells us it's a regular hexagon, what can we already assume? That all these sides are congruent and all these angles are congruent because it gives that definition of regular. The expressions shown represent the side lengths of the hexagonal table. So since it told us it's regular, it gives us 2 sides that are expressions in terms of x, and they have to be congruent. So how would you figure out the length of the side? You would set up an equation to solve for x. So the equation to solve for x is we would show that 3x plus 6 equals 4x minus 2. And if you're not sure where this came from, this is in your textbook on page 44. It's the example. And we're doing pretty good with our algebra, but just as a review, since the variables are on both sides of the equal sign, it's like a teeter-totter. What we take away from one side, we have to take away from the other. So we get x minus 2 equals 6. Add 2 to both sides to get x equals 8. And many of you are doing this. You are coming to an answer like this and stopping. But you need to go back and reread the question. The question didn't say solve for x. It said find the length of a side. So if x is 8, we then plug 8 back into one of the side formulas. So in this case, 3 times 8 is 24. 24 plus 6 is 30. And if you look at the units, it's 30 inches. Okay, so the last thing I'm going to look for besides your vocabulary sheets being turned in, can you please turn to page 44 and please do guided practice number 3. And those are the first 2 things that I'm going to check on Monday for your homework. Hope you guys have a great weekend. I really hope it's not Sunday night when you're watching this, but if it is, hopefully the Lions won, and hopefully Freeland beat Swan Valley tonight. I'm on my way to the game. See you guys later. Bye.